All right, everybody. Derivatives of products and quotients. Let's take a look. So, we did some shortcut rules the other day, and what we saw was some of those things worked okay, but there were certain situations where we're not going to be able to use our little shortcuts. They're not always going to be nice, pretty polynomials. So, here's the question. Okay. If you had some function f of x, which was x squared, and some function s of x, which was x cubed, excuse me, x cubed, and then we see some function f of x, which is capital F of x times lower or capital S of x. That's going to be x to the fifth. So in other words, ignore the f's and the s's. What we're saying here is if you had an x squared and you had an x cubed, and those are your two functions, and you're going to multiply them together, right? That's what that little dot means. Then x squared times x cubed is x to the fifth. We know that, right? Okay, think about your exponent rules. X squared times x to the third is x to the fifth. Okay, now this little multiplication thing in here means multiply, and we call it a product. Okay, so the question becomes, so I'm not finished. That's just the setup. So the question is, which of these is f prime? I'm sorry, lowercase f prime of x. Okay. Now, before we go anywhere, you can use your shortcut rule. You know what this is. So you know that lowercase f prime of x is what? Do your shortcut rule. Multiply out in front. 5 times x to the 5 minus 1 is 4. That's what we should be getting whenever we finish this out, right? Okay. So what the book's trying to show to us is which of these is f prime of x? Is it A, capital F prime times capital S prime? Okay. And I'm just going to say that's not it, but we'll see how it works out. So let's do that. Let's take those derivatives and see what happens. So here's capital F prime. Here's capital F. We want to take the derivative of that. Okay, what is that? Pull the 2 down. 2 times x, subtract 1 from the exponent. So it's just a 1. So we're good there. Times, take the second one, pull the 3 down. 3x, subtract 1 from the exponent, that's squared. Okay, most people at this point probably know, oh, that's not going to work for me because when I multiply, what do I have? 2 times 3 is 6, and x to the first times x to the second is only x to the third. Okay, is that what we should be getting? No, Dr. Webster, that's not it. Okay. So what we're trying to say is don't do that. Okay. So this is not how we take the derivative whenever we have two functions multiplied together. That's how a lot of people try to do it. Okay. A lot of people look at something and go, oh, x squared times x to the third, take the derivative of the first times, take the derivative of the second. That just does it for us. And the problem is that we're not allowing for combinations of things to happen whenever we just take the derivative of the first times the derivative of the second. So what people think is, oh, it worked that way whenever I added, right? Whenever I had an f of x plus an s of x, I could just take the derivative of the first one plus the derivative of the second one. And that was lovely for us the last time, but that won't work for us here. So don't do that. Don't take the derivative times the derivative. That's not it. So hopefully B is the correct one. And it is, I'm telling you now, but your book just says try this one. Derivative, or the first one times the derivative of the second one plus the first one's derivative times the second one. Okay. And I actually say this a little bit different. So if you hear me say it, I pretty much always say the first times the derivative of the second plus the second times the derivative of the first. Okay. So what you have to remember, and here's the nice part, this is addition in the middle. So order doesn't matter on that. So you can be a little bit loosey-goosey with the product rule. So you don't have to get it exactly in the right order. When we get to the quotient rule, you have to be exact. Okay, but here, so we're doing the first times the derivative of the second plus the second times the derivative of the first. It doesn't really matter which order as long as you have one of them and the derivative of the other one. Then the other one and the derivative of one of them. So you can't have the first times the derivative of the first. That's not going to work for you. Okay. And you can't have the second times the derivative of the second. That's not going to work for you. Don't do that. I see people try to do that. Okay. So let's try this guy with our two up there, right? We had capital F of x was x squared and S of x was x to the third. So let's try it. The first guy is just x squared. That's him. The second one was x third. Whenever we take that derivative, we actually already did it here. So 3x squared, okay, plus the second one was just x cubed times the derivative of the first. We already did that one. It was 2x to the first, right? Yes. Okay. Sorry. I had a moment where I went, "Ooh, is that right?" And I'm trying to think ahead on the math part of it, and it is. So multiply these together, x squared times x squared, that's a 3x to the fourth, right? And then multiply these together, x cubed times x to the first, that's also an x to the fourth, but 1 times 2 is just a 2. But I'm adding those, and what do I get? 5x to the fourth. Hey, look at that. 5x to the fourth is what we said our shortcut would give us, right? So 5x to the fourth is correct. So this is our formula. That's the one we're going to use anytime we're doing product rule. So let me give you that as an official rule, and we'll use it on a couple of examples and see how it goes. I know it looks a little bit more in depth than it is because it's two things plus two things. But once you use it, if you repeatedly tell yourself first times the derivative of the second plus second times the derivative of the first, get that as a rhythm in your head and it will help as you're working through the homework. You'll be like, oh, okay. So here's the rule. If y equals f of x equals capital F times capital S. I always have problems with the F's and the S's. They sound alike to me, similar. And if capital F prime and capital S prime exist, so in other words, we can't have weird stuff going on and their denominators being 0 and stuff like that when we plugged in the H equals 0, right? But if they exist, then here's our rule. F prime of x equals capital F of x, capital S prime plus S of x, capital F prime. Okay. First times the derivative of the second plus second times the derivative of the first. Okay. That's a rule. You can mark it somewhere. It's going to be on the formula sheet. You should have, you've already had the formula sheet, so it's in there, I promise, but you should be able to see it and recognize it and go, oh, okay, what's going on here? I got it. Okay. Remember, these have to start out as products to begin with, two things multiplied together. So here's our example, and we're going to stop for just a second. and say, does this even meet the product rule? So I've got f of x equals 2x squared times 3x to the fourth minus 2. Okay. So what I'd like for you to do before you just all willy-nilly apply this thing is look and go, this could be my first function, right? That's a polynomial. Times, there's not a dot there, but this is times, right? This can be my second function. Okay. So as long as you can keep those straight, then we can take this derivative. So there are two functions being multiplied. This is a product rule. That's what we're going to do. Use the product rule. So f prime of x equals the first, just like it is, don't do anything crazy with it. The first guy times the derivative of the second guy. Well, the second guy is 4 times 3. That's going to be a 12x. Subtract 1 from the exponent. 4 minus 1 is 3, right? And then this is a constant, right? Minus 2. That's just a 0. So that's what that is. Plus the second guy, just the way he looks. Don't do anything crazy to him. Just like he was written in the problem. 3x to the fourth minus 2 times the derivative of the first guy. Well, that's multiply that 2 out in front. 4x, subtract 1 off that 2 to the first power. So be a little bit careful. Again, you really need to know your exponent rules. All right, so here we go. F prime of x is equal to, these guys are being multiplied. 2 times 12 is 24. X squared times x to the third. The rule here is when you have the same base, you add your exponent. So x to the fifth plus, okay, be careful with this guy. This 4x in the back needs to be distributed into these parentheses. Okay, so 4 times 3 is going to be 12. Okay, x to the first times x to the fourth. Again, I'm multiplying like bases, so I'll add my exponents. Okay, and then 4 times negative 2 is negative 8. X to the first, I'm going to leave the 1 off. There we go. Okay. And now I see I have like terms I can combine. So f prime of x equals 24x to the fifth plus 12x to the fifth is 36x to the fifth minus an 8x. They're just kind of along for the ride. Minus 8x. That is really light. I don't know why that marker, that pen is coming out really light. 36x to the fifth minus 8x. There you go. All right. That's how it's going to work. So it's a different pattern. You have to be able to do first times the root of the second plus second times the root of the first. But once you get used to it, I feel like it'll go pretty well. I hope. Let's do another example. Okay, and some of you were asking me, how can I work some of this on my own, make sure I'm doing okay? And the answer is, if I were you and I was struggling, I would for sure pause and see, can I do this by myself? If you can't, then push play, do it with me, and then even write those questions off on a separate sheet of paper and kind of make your own sheet and say, I'll come back and work these by myself without the video. And if you can work them all by yourself without any tutoring, without any helps, then you're probably doing pretty well. Okay. Here's my next example. F of x equals 2x minus 9 times x squared plus 6. Okay. There's one and there's one. I think both of those are functions. I see they're being multiplied. So I say to myself, two functions being multiplied. I'm going to use the product rule. Do you see how this is more complicated than just those pretty polynomials I was working with last time? This is a polynomial times a polynomial. Could you multiply that out? Well, this one you could, but some of them you can't. They're just too crazy big stuff. So some of them you're not going to be able to multiply them out. So we just go for it like this. All right. Okay. We want to make sure on these simpler ones that we can do it before things get crazy. Here's my derivative. F prime of x equals the first guy, write him just the way he is, times the derivative of the second guy. If it makes you feel better, cover up the first guy so you're not looking at him. Okay. We're going to pull this 2 out. 2 times x. Subtract 1 from the 2. It's to the first. Plus, this would be a 0. The derivative of a constant is 0. But I don't need him. I'm just going to be done. Okay. Plus the second guy, just the way he is, x squared plus 6 times the derivative of the first guy. Well, what's that? It's really a 1 up here. Pull that 1 down. 1 times 2 is 2. X to the 1 minus 1 is 0. So that's 2 times 1, right? Derivative of negative 9, that's a constant. So it's a 0, right? All right. So here we go. The derivative here is, we need to distribute that guy through. I know he's in the back. If that bugs you, you can rewrite it. So it's 2x on the front times 2x minus 9. 2x times 2x is 4x squared. 2x times negative 9 is negative 18x. This is just a 2. 2 times 1 is a 2. Multiply him through that parentheses. Plus 2x squared plus 12. Okay. And then I see that I can combine some like terms here. So I'm going to do that to make them prettier. F prime of x equals 6x squared minus 18x plus 12. All right, there's my derivative. Okay, so what they're going to do at this point is they're going to start asking you some unusual questions about things like tangent lines. Remember, we talked about tangent lines before. So this particular problem in your book says, it's got some parts. It says find the derivative, and then it says, so this was part A, and then part B says find the equation of the line. Find the equation of the line tangent to the graph, tangent to f of x. F of x is graph at x equals 3. Okay. So let's see how well we remember what was going on with this. Okay. Whenever we did derivative before, we said this is the instant rate of change for this function, and you have to figure out what it is at each particular point. So for instance, this function is actually an x times an x squared. So that's an x cubed, and it looks like an S curve, right? That's kind of what my graph looks like for this guy. Okay. So the slope here, the average rate of change here versus here versus here versus here versus here, those are all different, right? So this is the instant rate of change, IROC, and you have to decide at what point, but they're telling me at x equals 3. I'm so sorry, I had to sneeze. Okay. They're telling me at x equals 3. So what does that mean? If I want to know the instant rate of change at a particular point, I'm going to plug it in. What's the instant rate of change? Remind me. For the tangent line, that tangent line I draw, say here, that's the slope of that tangent line, right? So that's why I want to find this. So f prime of 3, 6 times 3 squared, 18 times 3 plus 12. All right. Well, 3 squared is 9. 9 times 6 is 54. Okay. 18 times 3, is that 50? No. 54? 18 times 3. That is also 54. So this is 54 minus 54 plus 12. Well, clearly these two 54s are going to go away. I'm going to be left with 12. So what does this tell me? This is the slope of the tangent line at x equals 3. That's my slope. Okay. I happen to have found that slope by using the derivative because, again, this isn't a straight line. It's a curvy thing. So it changes every place I go to. Okay. So they asked me to find the equation of the line of a tangent to this thing. First thing I need is the slope. And then if you'll remember from the first test, y2 minus y1 equals m times x2 minus x1. None of this stuff is going away. You're going to still be using all that intense algebra review stuff. So, well, we've got that, but we need a point, right? So maybe pick a point. Um, where's the tangent line? Okay, so we're saying x equals 3 here, right? So let's plug that into my original function. I need a point, right? I need to fill in x1 and y1. So I know my slope. Some y1, I'll find it in a minute. 12 was my slope. x2 is generic minus, and we're going to plug in 3 because that's our point that we're at, right? X equals 3. So the 12 was this slope. That's how I got the 12. This is because we're at the point x equals 3. All right. So let's go back to the original. This is the slope of a line, so it should be in the original function, not on the derivative. Okay. So we come way back up here and we plug in 3. 2 times 3 is 6. 6 minus 9, that's a negative 3. 3 squared would be 9 plus 6, it's a 15. Plug in a 3, I get out a negative 45, right? So negative 45. That's my point that I just found. 3, negative 45. Okay, so that's what I'm using for my x's and my y's. Is that all right? Okay, so here we go. All we got to do now is solve for y, right? Let's clean this guy up a little bit and make it look pretty. Y minus and a minus is a plus. 45 equals, I'm going to distribute this guy through. 12 times x sub 2, or 12x. 12 times minus 36, right? 12 times 3, negative 36. Okay, and then the last thing for me to do here is subtract off of 45. Subtract off of 45. So I've got y equals 12x, and that's going to be minus 81, right? 1, carry the 1, yep, minus 81. There you go. That is nice. So this is the equation of the line that is tangent to this graph at x equals 3. Okay. So real quickly, let's just ask a secondary question. This was also in the book. Or I guess it's a third question off of this, part C. It says, okay, looking back at this, we have our derivative. It says, where is the tangent line? We're going to have to think here. Where is the tangent line to f of x horizontal? Okay. So again, here it's some S-curvy thing. Where is it horizontal? Horizontal means flat, right? So where would it be horizontal? At this maximum and this minimum, right? So that's where the flat tangent lines would come in. And so what we see is, what we're asking for is a horizontal line. What kind of slope does that guy have? And you should know this, m equals 0 on a horizontal line, right? Okay. So that's what they're asking me. Where in the world will I have m equals 0? Okay. Well, this is how we find the slope. I'm sorry. This is how we find the slope of a tangent line at any point, right? This was it, my derivative. So once I have my derivative, what they're asking me for is this is the slope of the tangent line. Where is it 0? And that is a concept we're going to use for a long time in this class. So start telling yourself, take the derivative and set it equal to 0. That's what they're telling me to do. Take the derivative, set it equal to 0. It's exactly what they want me to do here because I want to know where is that instant rate of change going to be equal to 0. Okay. Now, this guy, all three of these terms have a 6 in common, so I'm going to divide that out. And whenever I divide everything by 6, 0 divided by 6 is just a 0. 6x squared divided by 6, that's x squared. Negative 18x divided by 6, that's negative 3x. And that's a plus 2. Okay, so you don't have to divide out the 6. You can work with those bigger numbers, but I like working with these smaller numbers because it's easier for me to factor it. Okay, remember that factoring mess that I told you about before? You're going to have to be able to factor. It's staying with us for the rest of the class. So you gotta figure out how to factor. Okay, so real quickly, 0 equals x and x, 2 negatives, a 2 and a 1. It doesn't matter the position. That's x squared minus x minus 2x gives me the minus 3x, and then a negative and a negative is a positive 2. So I know that this guy is horizontal at, take these, set them equal to 0, so x equals 2, or take this one, set it equal to 0, x equals 1. Those are the two spaces where it's horizontal. And by the way, we figure it's going to be 2 spots at most because those are the turning points off of a cubic, right? So 2 turning points, there's a max and a min. That's going to give me 2 spots where they're horizontal. Okay. So we're going to start tying in a bunch of the topics that we already dealt with. Notice in that last kind of problem, I dealt with exponent rules, I dealt with factoring, I went back to some of the ideas of tangent and slope and IROC and all of that. So it's kind of like all of this stuff comes together here. So you've got to be able to work it. I'm going to give you an example. I want you to work it. This is one that's a product rule. F of x equals 2x plus 9 times x squared minus 12. And again, I'm telling you it's a product rule, but hopefully you're able to look at this guy and go, oh yeah, here's one function, there's another function, and see for yourself, oh yeah, I think that's a product rule. That's going to be one of the things for test 2 that you have to be able to do is look at it and go, what kind of rule do I need to use here? So I'm going to pause, I'm going to work it out. You pause and work it out, and then come back and see if you got what I got. We're trying to find the derivative using the product rule. All right, so there's my derivative. I saw it was product rule. First times the derivative of the second. First times the derivative of the second plus second times the derivative of the first. Write it out, multiply it out, distribute, simplify it, combine like terms. There it is. Okay. If you wanted to at this point and you were just trying to see if you can do it, you could go ahead and factor that guy, see if you can find where it equals 0. Take that derivative, set it equal to 0, solve for x, that kind of thing. It wasn't part of the problem, so hopefully you got that derivative right. Correctly applied the product rule, and we're going to move on. All right, so here's your next question. Okay, We're given capital T of x equals x to the fifth. Capital B of x equals x squared. Okay. And they actually are using these variables because it's going to be the top guy and the bottom guy because we're going into a quotient rule. So the question is if f of x, lowercase f of x, equals top guy divided by bottom guy, t of x divided by b of x, so that we see we have a function divided by a function, then we know this would be x to the fifth over x squared, right? And we know we could simplify that. Okay. So if we had off to the side, if f of x was x cubed and we wanted to take the derivative of that guy, 3x subtract 1 from the exponent, it would be pretty fast and easy for us, right? If this reduced down, that's what we would be getting. Okay. So the question is which of these, if we know we want to get to this, okay, here's what I'm given. That's my setup. Which of these is f prime of x? Okay. And it's going to be similar to the last time. They're going to give me two options and we're just going to work them out and see what happens. So the first one is t prime of x divided by b prime of x. Okay. Now, without doing the math here, think about it for just a second. It didn't work for product rule that way, right? We couldn't just take the derivative and multiply it by the other derivative. So we have to come up with those interacting combinations. This one's probably not going to work. It's probably not derivative divided by derivative, but we'll see. So let's see what we got. X to the fifth here, if we took that guy's derivative, it would be 5x to the fourth, right? Okay. And x squared, if we took that guy's derivative, it would be 2x to the first. And when I go to do this division here, it's 5 over 2. Well, that won't even go evenly. X to the fourth over x is x to the third. Is that going to work? No, Dr. Webster, that's not it. Okay, no. Okay, that's not it. So we don't do it that way. Okay, so remind yourself it's not just the derivative divided by the derivative. It's not that easy. The product rule and the quotient rule, there are actual formulas we're going to use. So their B question, their B part of the answer says it could be this guy, but we know it's not. B of x, I'm going to write it out first and then I'll tell you my mnemonic, times t prime of x minus t of x times b prime of x all over b of x squared. Okay, so this literally means take the bottom function just like it is, multiply it times the derivative of the top function, minus the top function, multiply it by the derivative of the bottom function, and then the bottom squared. Okay, that's what they're literally telling you to do. And notice this is a minus sign, so the order matters here. Okay, it's got to be the bottom guy times the derivative of the top has to go first. And after the minus sign has to be the top guy times the derivative of the bottom. It's got to be in that order. So you're going to have to know it's bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. It will be on a formula sheet. You're not going to have it memorized, but you absolutely have to remember which one it is. So the saying that I learned when I took calculus was low D high, high D low, low low. Okay. And that's the way I remembered it. Okay. The low guy, the bottom guy times the derivative of the top guy, low D high, high D low, low low. That's the way I say it in my head every time I go to take a quotient rule. Low D high, high D low, low low. Okay. So if that helps you, then remember it. If that doesn't help you, then go find some mnemonic online or make up your own that will help you remember which one it is. And again, hopefully you work a whole bunch of homework questions and it just sticks in your mind. The more you use it, the more it's stuck. Okay. Low-de high, high-de low, low, low. That's how I remember it. Okay. So, and there's a minus sign in between these guys. All right. You remember it how you want to. We're going to see why this works. Okay. And again, it's those interacting combinations that are working. Remember, the bottom guy here was x squared. So this says take the bottom guy just the way he is. Don't do anything to him. X squared times the derivative of the top. Well, the top guy was x to the fifth. So his derivative, we took it a minute ago, 5x to the fourth. Okay. Minus, because there's a minus in the formula, the top guy, just exactly the way he is, x to the fifth, times the derivative of the bottom guy. Well, here's my bottom guy, x squared. His derivative is going to be 2x to the first. We don't care about the x to the first, or the first, I guess. And then the bottom squared is just x squared squared. Okay. We're just going to leave it like that. Okay. And a lot of times, this one's not so bad, x squared squared. We can make that into x to the fourth. But a lot of times, oh, excuse me, I'm sorry. A lot of times that bottom guy is going to be a binomial or a trinomial. So it's going to be squared, and we are not going to do that math. We're just going to leave it alone. Okay. So let's see what this is. Let's see how we do. Okay. Because right now, this doesn't really look like 3x squared, which is what we know it should be, right? So let's see where we are. All right. Multiply these guys together. So this is 5x to the sixth, right? Minus, from the formula, minus 2x to the sixth. It's really important because these are always going to be things that will combine if we've done it right. Okay. And x squared squared is x to the fourth. Now, when I combine these, I get 3x to the sixth, right? So when you're multiplying like bases, you add the denominator or add the exponents. When you have common terms, you can just add and subtract like normal. 5 apples minus 2 apples is 3 apples. Okay. And now we need to use another exponent rule, which is division here. X to the sixth divided by x to the fourth. We subtract those exponents. This guy goes away, and that becomes an x squared. 3x squared. And sure enough, the interaction between all those powers, 3x squared, is what we knew it should have been from our shortcut rules the last time. Isn't that cool? Okay. So would anybody think that this is the formula for taking a derivative of a quotient? No. But some smart math guy hundreds of years ago came up with that, and sure enough, if the derivatives exist, this guy will work for a quotient. Okay. All right. So that's the one we're going to use. I'm going to put him to the side. I'll bring him back in a second, make sure we do them right. Let's do a couple of examples of this and make sure everybody can do it. And then we'll go from there. All right. What if f of x equals x squared over 2x minus 1? Okay. Again, it's not a pretty polynomial. I look at it, I say that's division, so this guy's going to be a quotient rule. So you're going to have to make that decision. Right now, it's an easy decision because the quotient rule is what we're working on, but later it won't be quite so easy. Okay. So just kind of for my own sake, I'm going to say the top is x squared. I'm not going to do this every time. I just want to make sure everybody understands what we're doing. The bottom function, b of x, is 2x minus 1. So if you're having a problem with that, go back and work it out. Okay, make sure you can figure out which one's your top, which one's your bottom. So here we go. F prime of x equals, okay, the bottom guy, just like he is. Write him down. Times the derivative of the top. Well, what's the derivative of the top? Pull that 2 down in front. Subtract 1. Right? Minus 1. That's a 1. All right. Bottom times the derivative of the top minus, because there's a minus in the formula. Bottom times the derivative of the top minus the top times the root of the bottom. So the top guy is x squared times the derivative of the bottom. Well, the 1 is negative 1 is a constant, so that's just a 2. Okay. All over, and the formula says you take the bottom just like it is and square it. 2x minus 1 squared. And like I said, most of the time we're going to leave this written just like that. Don't multiply it out. There's no reason for it. If it'll reduce, we'll see it in a minute that if it'll reduce, it will. If it doesn't reduce, then there's absolutely no benefit to multiplying that out. You're just making extra work and possibly a time when you can make a mistake. So here we go. F prime of x equals, I need to distribute this 2x, so that's 4x squared minus 2x. And then this is minus 2x squared all over that bottom stuff, right? 2x minus 1 squared. So the only thing here for me to do is I can combine these like terms. So 4x squared minus 2x squared is 2x squared minus 2x all over 2x minus 1 squared. Okay. So the only thing you could possibly do here is if this factored outright, you might be able to get rid of one of these x squared guys here. But think about how this factors. If I pull a 2x out, I'm left with an x in that first term and a minus 1 in the second term. So even in a factored format, this x minus 1 and that 2x minus 1 will not reduce. So it doesn't help you at all. So no reason to multiply that out. And there's really nothing I can do with it. If you want to leave it factored on top, you can. If you don't want to bother factoring it on top, that's okay too. I'll take either one of them because nothing reduces, so it doesn't matter. There's my derivative using my quotient rule. All right. Is everybody all right with that? That's the way these are going to go. You're just going to look at them. You're going to see that they are quotient rules. You're going to pull out that formula, that equation, and you're going to work it out. So here's another one. And I'll give you the actual quotient rule in a second. Okay. How about this guy? Y equals t squared minus t over t squared plus 1. Try that guy. I'm going to push pause. You push pause. We'll come back and see if we got the same answer. Okay, so here we are. I did mine. I've got the bottom times the derivative of the top. This guy, when I take the derivative, is 2t. Remember, the derivative of negative t is just 1, right? Because I pulled the 1 down. T to the 1 minus 1 is 0. That becomes a 1. So 1 times 1 is just a 1. So that's how I get the derivative of the top. Minus the top, just the way it is, times the derivative of the bottom. Well, that just becomes 2t, right? The derivative of the 1 goes away. All over the bottom squared. I think that the 2t to the third and the negative 2t to the third go away. These t squares will combine. And I've got t squared plus 2t minus 1 all over t squared plus 1 squared. All right, so that's where I think we are on that one. So if you need to pause it, rewind it, go back and see. Hopefully we got the same answer there and all is good. All right. Let's do one more like this, and then we're going to see a different way of looking at it. So y equals x squared minus 3 over x squared. We're going to use the quotient rule one more time, and then I'm going to do this actually probably a couple of different ways just so we can see what's going on. Okay, so um, top and bottom, just straight up quotient rule. So y prime equals the bottom, x squared, times the derivative of the top. That's a 2x. This becomes a 0. Everybody good with that? Minus the bottom times the derivative of the top times the derivative of the bottom. That's a 2x all over. The bottom squared is x to the fourth. Okay, so when I go to simplify this, y prime equals, these guys get multiplied. That's a 2x to the third. Be careful with this guy because the 2x is being distributed in, but also the negative. I think the last one had that too. Also the negative. So be careful with those negative signs. I tend to make mistakes with those too. So 2x times x squared is 2x to the third, but it's negative. Okay. And 2x times negative 3 is negative 6x, but that's negative. So that's a positive 6 all over x to the fourth. So what we see here is these x to the third guys go away, and I get 6 over x to the fourth. Okay, that's not too bad. That's a cool little use of the quotient rule, no problem. But there's a couple of other things you could do here. So this problem can be worked multiple ways, and when I do that, I'm going to say or. When I do that, I've got to make sure that I get the same answer. Like it should come out with the same answer no matter which way I do it. So one of the ways one of the ways that I can deal with this is I can do what we did when we were dealing with the shortcuts and move this guy to the top. When I do that, I'm just rewriting for right now. X squared minus 3 times this exponent becomes a negative 2, right? And then I can say, oh, I can multiply that through. Again, I'm still rewriting. I'm just distributing here, right? And think to yourself, what's the rule whenever I'm multiplying like bases? I keep the base the same and I add the exponents, right? Okay. So keep the base the same, add the exponents. So a 2 and a negative 2, what's that? 0, right? And then here, same difference, but I'm going to go minus 3 times x to the negative 2. I feel like I just missed something. Hang on. I'm sorry. Negative 3 x to the negative 2. Let me make sure. Multiplying like bases, you're adding. I think that's right. So that's going to become a 1, right? Okay. Why do I have, hang on. I messed up here. Ha ha ha. Let us check something out. I'm sorry. I was like, I'm not getting the same answer in my head. Here, y'all let me do it too. Negative 3 times 2x times a negative should be positive 6x, right? X. So this is 6 over x to the third. That's going to work much better. And see what I did? I was like, oop, I think I'm doing it right this time. So I must have made a mistake before. I apologize for that. Y'all just let me do it. 2x times negative 3 is negative 6x. I probably had written on top of that x and didn't see it. And then it's a negative. So negative 6x times a negative is a positive 6x. And there they go away. There's just a 6 over x to the third. Okay, sorry about that, guys. Okay, anyway, now I see, oh, this is just 1 minus 3x to the negative 2. And when I go to take this guy's derivative, y prime equals, derivative of a constant is 0. Negative 2 times negative 3 is a positive 6. And then be careful with this because it's x. it's -2 subtract 1. We did this last time. -2 minus 1 is a -3, right? And so these are the same now, right? I just need to rearrange that. When I move the x cubed to the bottom again, it loses its negative sign. So that 6 over x to the third, 6 over the x to the third. Those are the same, okay? Or, so we're doing great, okay? There's other ways to see this, and not probably doing all the ways. Okay, so there's just lots of ways to look at these. You don't always have to use the quotient rule. I didn't use quotient rule there, right? I rearranged this guy and I moved it. I made it into what basically looks like a polynomial here. Okay. It's a power function for sure. It's not polynomials because of the negative. But anyway, I made these into, no, it would be okay. Yeah, that would be okay. Anyway, I made this into a power function, and then I could just use my power rule. So my shortcut is nice. Okay, so here's another way I could rewrite this. Both of these numbers on top get this exponent or get this denominator, right? They both get that denominator. Okay, so I could split this fraction. That's what it's called. If you split the fraction, they both get the denominator. They both get the denominator. Okay, so they have to share that denominator because they were sharing it here. Whenever I split it up into two separate fractions, they have to share it there. Why would I bother doing that? Some people like this. And the reason that they like it is because x squared over x squared, they see it right there, right? Ooh, I want to reduce those. And you just can't mark it out like that. You have to split it first and then you can mark it out, right? So now it's 1 minus 3 over x squared. Well, that becomes a little bit easier for me to take the derivative of that guy, right? Let me put this up here. Okay, if my y was 1 minus 3 over x squared, then I can do this piece by piece, right? Y prime equals, take the derivative of the constant. That's a 0. You can do this one any way you want to. Let's do this bit right here by the quotient rule, okay? So it's the bottom times the derivative of the top. Well, what's the derivative of the top? That's constant, right? So it's 0. Okay. Minus the top guy times the derivative of the bottom. What's the bottom guy? 2x, right? Okay. All over the bottom guy squared. Okay. Well, what happens when I do x squared times 0? That just goes away, right? So now I've got minus, is it a minus? Hang on. The bottom times the derivative of the top minus, oh, the top guy is negative. The minus, this minus is from the formula. This minus is in there. So it's a positive 6x over x to the fourth. Okay. And then we see, just like earlier, those x's will reduce out. I get 6 over x to the third. And sure enough, that's the same thing. Okay. So there's lots of ways to work these out. You didn't have to use quotient rule here, right? I almost said, let's rewrite this guy so that it's 1 minus 3x to the negative 2. And then you could just take that like a power function, straight shortcut. Okay. So there's lots of ways you can do them. And it's really, unless I say on the test, use the quotient rule here, it's really going to be a matter of you looking at a problem and going, how can I take this derivative? And if you think, oh, what if I move this x squared and put it on the top and make it a negative exponent, then that's fine. As long as you're using legitimate exponent rules, you'll be fine. Okay. All right. So let's get our quotient rule in here. Okay, quotient rule. Here's one of my rules. Mark it down somewhere. Okay, make sure you've got it. And it says if y equals f of x equals t of x divided by b of x, and t prime of x and b prime of x exist. Okay, they have to always exist. Then f prime of x equals the bottom guy times the derivative of the top minus the top guy times the derivative of the bottom all over the bottom guy squared. There. Oops, sorry. Let me do like that. There is your rule. Okay. So absolutely you can do that. And my shortcut again is low-de high, high-de low, low, low. Okay. So there are a lot of other problems in the book that you can work with if you want to. Go for it. Go work on your homework, all that good stuff. Do some examples. And just practice with these. You're going to have to practice with these. I've got one more sitting here I want to give you. And then I've got a word problem we're going to work through. So f of x equals 2x over x squared plus 3. Do that on your own. I'll do it on my own. We'll come back. Press pause. Okay, I'm not going to belabor this one too much. I hope you did it and had no problem. Here's my work. If you need to pause so you can see it before I move this page, go ahead. I think the answer is 6 divided by parentheses 2x plus 3 squared. Okay, and I hope that's what you got because hopefully all your practice is paying off. All right, so pause if you need to. I'm moving this. All right. Okay, one word problem on this, just so you can see the way this is going to look in your homework. And then we'll go from there. There's a sales problem. It says a video game company looks at its sales and projects the total sales of a new game. And we're going to say T months after being introduced. So again, this is kind of how do we know this? I always get that question. How do you know that? Well, it's given to me in the problem, but in the real world, if you were working with a really big company, they would have people who go out and do marketing, people who go out and do surveys, people who go out and beta test things and say, hey, we got this new video game that's coming out. Would you be likely to buy it and things like that? So they come up with these formulas. So you're not necessarily going to have to come up with these formulas, but these people do. Okay. The cells T months after being introduced. So we introduce it in April. May would be month 1, June would be month 2, and so on and so forth, is 125 T squared over T squared plus 100. Okay, that's what they think this guy is going to look like. Okay, now just look at that equation for a second, that function that they gave me, and think to yourself, is that going to work with a power rule? And I hope you're saying, no, Dr. Webster, that's not going to work with power rule because these aren't all just written like a pretty polynomial, right? Okay, we've got a function divided by a function. And yes, we're in the quotient rule section, so we know this should be a quotient rule unless I did something weird to you, trying to mess with you or something, which I'm not. I hardly ever mess with my students. Okay, so we know that, but on a test, you're going to have to look at that and go, oh, function divided by a function, that's a quotient. Let me use my quotient rule. Okay, so hopefully you can do that pretty quickly and go, okay, let's use the quotient rule because it says find s prime of t. Okay, so one more time, you go ahead and figure that out. S prime of t is going to be the bottom guy just like he is. Don't change him, just the way he is. Times the derivative of the top. Well, that's going to be 2 times 125. That's going to be 250. T 2 minus 1. If you need to write it there, or if you need to write it here. If you need to write 2 minus 1 here, then write 2 minus 1. That's fine. And then come back and change that later. It's one extra step. It's not that big of a deal. Okay. So it's bottom times the derivative of the top minus from the formula. That's in the formula. That's a minus sign in the formula. So make sure it's a minus. Bottom times the derivative of the top minus the top, just the way it looks originally, times the derivative of the bottom. Well, what's that? This guy's going to be a 0, right? Derivative of 2t is, the derivative of t squared is 2t, because you multiply this out in top, out in front, and subtract 1. And then the derivative of 100 is 0, because that guy's a constant. All over the bottom guy squared. Okay. T squared plus 100 squared. There's that. And then you do have to clean these up for me. You can't just leave it like that. I will say, if you knew it was the quotient rule and you got this far, if this was, say, a 5-point question, you would get probably 3 points for that. But you're not going to get the full credit until you pretty it up for me. Okay, it's got to look nice. So the derivative of s is equal to t squared times 250 t squared is 250 t to the 4th. I'm sorry. It's not a square. I wrote it like that. That's why I don't normally do that. It's times the first. So t squared times 250 t to the first is t to the 250 t to the 3rd. Okay. 100 times 250, that's 25, 0, carry 2 zeros from the 100. Multiply that on your calculator if you need to. T. Okay. And then this guy is just going to be one term. It's minus 125 times 2 is going to be 250. And the t squared times the t is going to be t cubed. Okay. That kind of looks interesting to me because, hey, look, those are going to go away. The bottom is just right there. These are opposites. They're going to go away. They reduce out, however you want to think about that. Okay. And then I've got S prime of t equals 25,000 t. I was just making sure I had the right number of zeros there. Over t squared plus 100 squared. Sometimes I mess up my zeros, so I'm just trying to not make mistakes with you guys so I don't have to come back and fix them later. Okay. Excuse me. I'm just tired tonight. There is my derivative. Hope that makes sense. Hope everybody can do it. Part B says, okay, find S of 10 and S prime of 10 and interpret. Okay, so S of 10 is the original cells function, right? So that's just plug in 10. We can do that. Let's find it. 10 squared is 100 times 125. So the top's going to be that large number, 125, or I'm sorry, 12,500. There we go. And the bottom's going to be 10 squared plus 100. So the bottom's going to be 200. So what's 12,500? 12,500 divided by 200. 62.5. Oh, I'm sorry. There's a glare. 62.5. Okay. So S of t is 62.5. Okay. Interpret that for me. This was time in months, right? T was 10. So 10 months after we reduce this particular video game, we're going to sell 62.5. I apologize because at the very beginning, I ignored the fact that in the problem, it said in thousands. Okay. So they're working with small numbers, but they're saying 62.5 thousands. Okay. So 10 months from now, we release the thing. In 10 months, we think that we're going to have 62.5 thousand cells of this video game. Okay, cool. Okay. Now, what is this? Remind me. This was from the last section. S prime of 10. This tells me how much cells I will have the next month. So this is this much sales in a total of 10 months, right? We want to know just in the next month. So just in the 11th month worth of sales. Okay. Now it's not going to be probably 62,000 because that was over 10 months, right? This is just 1 month, the 11th month's thing. And when I see this, I go, I'm going to plug the 10 into the derivative right here. Right? Okay. So let's see. 25,000 plus times 10 is going to add a 0, right? That's 250,000. Divide by 10 squared here is 100 plus 100 is going to be 200 squared. Okay. So let's see what that says. 250,000 divide by 200 squared. 6.25. And again, remember this is in thousands. Okay. Why is this number so much smaller than this number? Because this is just 1 month, the 11th month. So like if we release this in January, this is how many we would sell through October. They expect 6.25 million or thousand just in the month of November, right? So this is a total of 10 months. This is just the next month. So be careful. Remember how to interpret these. This is marginal. Whenever I'm dealing with derivative, the marginal sales here or the next month, that's what it would be. Okay. So estimate, the last part here says estimate, sorry, out of space on this page. Estimate your total sales in the first 11 months. That one's actually not too bad. Why is it an estimate? Because this is just a prediction, first of all. And second of all, because we're doing a derivative. So that's an approximation, right? This is not an exact answer. This is their approximate. So how could I get a total for the 11 months? Total just means add, right? So the first 10 months plus what we think we're going to do in the 11th month. That's going to be, let's see. 62.5 plus 6.25 is 68.75. But remember, that's thousand. Okay. So if you wanted to see that in your calculator, you could say times 1,000. It'll add 3 places on it, right? So we can estimate. Oops. So estimate 68,750 games sold in less than a year. So that's probably pretty good. I don't know. Maybe the video game seller will think it's not that good, but I think that's pretty good. Okay. So that's it for the product rule and the quotient rule. Make sure that you understand all of this. Make sure you've taken good notes on this, and then go try out your homework and let me know what you think. If you have questions, let me know. Thanks. Have a great night.